Julia?
Thank you so much, Sebastian, for this really warm introduction. I only wish that we were doing this in person, and I'm humbled and really happy to be speaking to such a broad audience today. And as you mentioned, there are people here in the audience who come from any number of disciplines. And so I thought, what should I present that would be of interest to everybody to some extent? And I zoomed in not on particular papers, but rather on the comics, as you will see here. So this is going to be our common ground for the conversation. So a little bit more seriously, it will be my pleasure to discuss the challenges of designing, developing, and deploying data-intensive systems responsibly. And I spent a very long time resisting the use of AI as synonymous with data science, but I lost that fight. And, in the spirit of, if you can't beat them, join them, I'm going to use data science and data-intensive systems and AI almost interchangeably in my talk today. So still, in an attempt to get our terminology straight, I'd like to propose for the purpose of today's discussion that we think of AI as a system in which algorithms use data to make decisions on our behalf or to help us, humans, make decisions. And I'm showing here some examples that support my definition. The first is Roomba, a robot that helps us clean. And then there is chess playing AI, and a self-driving car, and an automated hiring system. These examples and many more underscore that we see substantial promise in the use of AI. We look to these systems to make the lives of each and every one of us more convenient, to accelerate science and boost innovation, and even to improve the ways in which society is governed. But the reality is that machines make mistakes. A customer service AI at your favorite online shoe store may misunderstand your order, and the wrong pair of shoes will be shipped to you. Annoying as this may be, consequences of such a mistake are not severe, and they are reversible. You can just return the shoes and hopefully get a refund. However, there are cases where mistakes can lead to catastrophic, irreversible harms, even to the loss of human life. And here I'm giving an obvious example, and that is an autonomous car. That's an AI that is about to make the vehicle cross an intersection, and that does not recognize a person on a bicycle as one of the types of objects that it would expect to see on the road. The car would then continue on its path, running the cyclist over. To dive deeper into this conversation, let us consider a domain where technology is used ever more broadly, and where the stakes of a mistake to an individual, a population group, and even to society at large cannot be overstated. That domain is automated hiring. The hiring process is commonly described as a funnel that I'm showing here graphically on this slide. It's a sequence of data-driven, algorithm-assisted steps in which a series of decisions culminates in job offers to some candidates and rejections to others. The process starts when employers source candidates with the help of ads or job postings, which are often carried out on social media platforms like Facebook or LinkedIn. Next, during the screening stage, employers assess candidates by analyzing their experience, skills, and characteristics. This stage uses a variety of AI tools, including resume and social media profile screeners and game-based assessment. Through interviewing applicants, employers continue their assessment in a more direct fashion. And this too is often done with the help of AI, for example, using video and speech analysis methods. During the selection step, employers make final hiring and compensation determinations. And here as well, predictive analytics and AI can be used. So why are algorithmic hiring tools so attractive? Well, first, they promise to help employers, large and small, hire more efficiently, source and screen candidates faster and with less paperwork, and select candidates who will likely do well on the job. These tools are also meant to improve efficiency for the job seekers, allowing them to apply with a click of a button, matching them with relevant positions, and facilitating the interview process. And we also often hear the argument that the use of these tools can help us improve workforce diversity. And indeed, an argument being made very frequently is that because humans are biased, we have no choice but to use machines to step in and hire on our behalf. I'm showing here an excerpt from a famous study by Marianne Bertrand and Sendil Mulainatan, who back in the analog days of 2004 manipulated perceived gender and race on resumes and observed that applicants who were perceived by the employers as male and white received substantially more callbacks on the very same resumes. So are algorithmic hiring tools living up to their promise? One of the earliest indications that there's cause for concern came in 2015 with the results of the Ad-Fisher study out of Carnegie Mellon University. The authors ran an experiment and found that ads for high-paying jobs were shown far more frequently to men than to women. This brings back memories of the time when it was legal to advertise jobs by gender in newspapers. In the United States, this practice has been outlawed in the 1960s, but it still persists in the online environment. As another example, in late 2018, it was reported that Amazon's AI recruiting tool that was developed with the stated goal of increasing workforce diversity, in fact, did the opposite thing. The system taught itself that male candidates were preferable to female candidates. It penalized resumes that included the word women's, as in women's chess club captain, and downgraded graduates of 2 all-women's colleges. Other examples of discrimination include shutting out people suffering from mental illness, such as depression or bipolar disorder, on the basis of online personality tests, even if they have the right skills for the job, and of showing ads that are suggestive of a criminal record when Googling for African-American sounding names, and doing so far more frequently, statistically significantly more frequently, than when Googling for white sounding names. And this happens even if you control for whether the individual in fact has a criminal record. This, of course, is problematic because employers often Google an applicant's name as part of an informal background check, as they decide whether to consider a candidate or whether to make them an offer once they have interviewed for the position. So to summarize, we are, of course, concerned with the use of algorithmic systems in hiring. Their effects are often discriminatory, reinforcing results of historical disadvantage. Discrimination is often linked to the term bias, a term that is used by the technical community ever more frequently and that is still poorly understood. I will discuss bias in a couple of minutes. But in addition, or perhaps even before worrying about bias, we should ask whether these tools actually work. Are they picking up useful signal from the data, or are they an elaborate coin flip at best? As Arvind Narayanan, a computer science professor at Princeton depicted here, puts it, are these tools AI snake oil? If a tool helps improve workforce diversity, if it admits a sufficient number of candidates of each required demographic group, but its decisions are otherwise arbitrary, can such a tool be considered fair? What if these decisions are worse than arbitrary? What if it's picking up signal like a person's disability status, and we have no way to know that this is in fact happening? What if it's measuring something about a job applicant that we have no reason to believe to be relevant for the job for which they are applying? How can we know whether a tool works? The obvious yet overlooked answer is that because AI tools are engineering artifacts, we should not take the claim that they work on faith. To check whether they work, we should put the science back into data science and use the scientific method, which always starts with an observation, is followed by the formulation of a falsifiable hypothesis, one that can be proven false. Next, an experiment is designed to check whether the hypothesis is falsified, and if so, we refine the hypothesis, design a new experiment, rinse and repeat. As the philosopher of science Karl Popper famously said, a theory or idea should not be scientific unless it can, in principle, be proven false. An appropriate hypothesis in algorithmic hiring is one that helps us ascertain that the tool indeed selects employees who do well on the job and is better at predicting job performance than a random guess would be. In the complex ecosystem in which automated hiring tools are commissioned, developed, and used, we must ask ourselves who is responsible for ensuring that these tools are built and used appropriately, who is responsible for detecting and mitigating unfairness that leads to discrimination, and for controlling the proliferation of snake oil under the fancy label of data science and AI. One of my main points today is that we all are responsible. But practically, where do we go from here? As a technologist and an engineer, I'd like to understand the following. Technology created many of the problems I spoke about, or it exacerbated them, made them worse. Can we use technology to fix some of these problems? And I'd like for us to step back and think carefully about the role that technological interventions, such as data and model debiasing that you surely heard about, can play in this conversation. This discussion is necessary to help us find a pragmatic middle ground between the harmful extremes of techno-optimism, shown on the left, a belief that technology can single-handedly fix deep-seated societal problems like structural discrimination in hiring, and techno-bashing, shown on the right, and that is a belief that any attempt to operationalize ethics and legal compliance in data science and AI will amount to fair washing, and so should be dismissed outright. To have this conversation, I'd like to recall a classic. In their seminal 1996 paper, Batya Friedman and Helen Nissenbaum identified 3 types of bias that can arise in computer systems. I represent them here with a 3-headed dragon. Pre-existing, technical, and emergent is what the heads read. Pre-existing bias exists independently of an algorithm itself and has its origins in society. Technical bias is introduced by the operation of the technical system, and it may exacerbate pre-existing bias. Finally, emergent bias arises in the context of use and may be present if a system was designed with different users in mind or when societal concepts shift over time. We will fight the bias dragon with the help of data equity. First, equity as a social concept is about treating individuals differently depending on their endowments and needs, to provide equality of outcome rather than equality of treatment. Data equity is the embodiment of this idea in data-intensive systems. My colleagues Bill Howe, H.V. Jagadish, and I coined this term, and we see data equity as having 3 major facets. Representation equity refers to deviations between the data record and the world the data is meant to represent, often with respect to historically disadvantaged groups. Access equity is concerned with having access to information, features, data, and models needed to evaluate and mitigate inequity. Finally, outcome equity refers to downstream unanticipated consequences outside the direct control of the system. I will now go through each of these data equity types to give the flavor of the positioning. As will become clear, purely technical solutions will never be sufficient. They have to be based on explicitly stated values and beliefs that in turn arise through public conversation and societal consensus. So let's start with representation equity. To think about this equity facet, I like to use the following metaphor. Data is an image of the world. It's mirror reflection. When we think about bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. we may systematically oversample or undersample particular parts of the world or otherwise distort the readings. Another interpretation of bias in the data is that even if we were able to reflect the world perfectly in the data, it would still be a reflection of the world such as it is today, and not necessarily of how it could or should be. I'd like to make a couple of points based on this. First, it's important to keep in mind that a reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it's a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of the distortions has to be explicitly stated and used as input to any technical interventions that we may attempt. The second point is that it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it should be, or if it needs to be improved. And if so, how we should go about improving it. This, once again, limits what we can expect of purely technical solutions. My third and final point is that changing the reflection does not necessarily change the world. If the reflection itself is used to make important decisions, for example, whom to hire, or what salary to offer to an individual being hired, then compensating for the distortions is worthwhile. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technical interventions, to propagate the changes back into the world, not merely brush up the reflection. Let me now give an example of a concrete technical approach that focuses on representation equity in set selection and ranking. Consider the task of selecting 4 candidates among 16 job applicants. Our goals here are twofold. The first is diversity. We wish to include 2 candidates of each gender, male or female, and at least 1 of each race, white, black, and Asian. The second goal is utility, maximizing the sum of scores of the selected candidates, subject to diversity constraints. You can see a list of candidates in the table here on the left, along with their scores. For example, candidate A has score 99, and L has score 83, and the higher score is considered to be better. Observe that male candidates have higher scores than do female candidates of the same race, and that whites have higher scores than blacks and than Asians. The highest scoring set of 4 candidates that satisfy the diversity constraints is highlighted in pink, and their combined score is 373. If we consider the selected set more closely, though, we observe a problem. And that is that we picked the best, according to score, white and male candidates, these are A and B, but we did not pick the best black, Asian, or female candidates. Note that this example was deliberately constructed to highlight the following. If some population groups have systematically lower scores, then it costs less to skip their best scoring members in the name of diversity. This runs contrary to the nature of the diversity objective itself, which is to equalize access to opportunity. This also represents unfairness under a particular belief system. Suppose that scores represent effort. For example, how hard someone had to study to do well on a test. We may take a relative view of effort and assert that scores are more informative within a group, within a demographic group, than across groups. And further, we may assert that it's important to reward effort. Taken together, these beliefs correspond to a luck egalitarian conception of equality of opportunity that I denote here with a rainbow unicorn. There is something that we can do. Consider the set of 4 candidates highlighted in blue. This set meets the diversity constraints, and its score is lower, just by 1, than the score of the pink set. This utility loss is inevitable, but in this case, it's very small. The blue set contains the top scoring candidates of both genders and the top scoring white and black candidates. And so it's much better in terms of rewarding effort across groups compared to the pink set. Having stated our beliefs and observed the trade-off between diversity, utility, and a particular kind of fairness, we are now ready to design a technical intervention. For example, we may compute unfairness for a group, like the female candidates that I'm showing here, as the ratio of the score of the lowest scoring selected candidate, K with score 83, and the score of the highest scoring skipped candidate, D with score 95. We can then reformulate the selection process to balance unfairness across groups. We did this and quite a bit more in the paper that I'm citing here, designing several fairness metrics of this sort and designing an intervention for both set selection that I just described and for ranking. Our intervention was an integer linear program that encoded all the necessary constraints, and we also ran experiments showing that the utility cost of balancing fairness is low in most cases. As another example, consider a dataset of candidates with the specified gender and race. This dataset is used by a moving company to hire K equals 4 best qualified candidates. They are the candidates B, C, D, and E that appear above the pink line. Note that the score attribute X represents a candidate's weightlifting ability, and that higher is better. The attribute Y is the outcome, and it represents the candidate's final qualification score. Candidates are ranked in decreasing order of Y, so higher Y is also better. The process by which Y is derived is hidden from us, but we do observe each applicant's attributes, including their score. We may have reason to believe, based on our knowledge of discriminatory practices in hiring, that gender, and possibly also race, impact how the qualification score Y is derived from weightlifting ability X. We are going to state our beliefs in the form of a structural causal model, or SCM. An SCM is a directed acyclic graph where vertices represent observed or latent variables, and edges indicate causal relationships from source to target vertices. The arrows pointing from gender, G, and that's sex and gender, and race, R, directly to Y, encode the effect of direct discrimination. We want to check whether such links exist in our data, and if so, to break them. And these links are shown in pink. Additionally, the SCM can encode indirect discrimination. G and R both impact Y through weightlifting ability X, and X is called the mediator variable. So the question is, should we or should we not allow gender and race to impact X? And with this framework, we have the flexibility to state that if impact of race on X is determined to be an effect in our data set, that it should be disallowed. On the other hand, the impact of gender on weightlifting ability can be considered legitimate. The SCM on the right encodes these beliefs. In it, X is treated as a so-called resolving mediator with respect to gender, but not with respect to race, as denoted by the color of the corresponding arrows. How do we use our beliefs, stated as a structural causal model, to inform an intervention? The idea is to compute scores, treating each individual in the sample as though they had belonged to one specific intersectional group, for example, Black women, and then rank on those scores. In a nutshell, the counterfactual score Y is computed by replacing the observed value of a sensitive attribute, such as white male, with the counterfactual value, Black woman, and then propagating this change through the structural causal model. Any directed descendant of gender or race has its value changed by computing the expectation of the new value of the sensitive attribute. And this operation is iterated until it reaches all the terminal nodes that are descendants of any of the sensitive attributes. If a mediator variable is non-resolving, then its value will be set to its counterfactual value in the process. If, however, it is designated as resolving, then we keep its observed value. The resulting ranking will be counterfactually fair, and we will use that new ranking to assign scores. For intuition, you can imagine all individuals in the data who have sufficient weightlifting ability, whether they are men or women, white, Asian, or Black, to look like Brienne of Tarth from the Game of Thrones, only darker, like in the image here of this knight who is wielding the 3 swords of data equity. Additional details, including experimental results that showcase the flexibility of our proposed method, can be found in the paper that I'm citing here. I would now like to switch gears and discuss access equity, the second of 3 kinds of equity that we will talk about today. Access equity is concerned with having access to information, features, data, and models that are needed to evaluate and mitigate inequity. The point of view I will take here is primarily of mitigating technical bias, making sure that we're able to catch and correct for the imperfections and distortions in the data as it travels through complex data science pipelines. Much exciting work remains in supporting access equity, both in terms of practical implementations and in forming a conceptual understanding of the interactions between pre-existing and technical bias and their impacts on equity. The fair machine learning research community considers this work out of scope. Their focus is on predictive analytics that take as input a nice, clean rectangular data set, crunch it, and produce a result. If we then notice that the result is such that no women are shown ads for high-paying jobs and no Black candidates are invited for job interviews, then we have 3 choices. Tweak the input data, for example, upsample or downsample some groups, tweak the algorithmic box, for example, add a regularization term, or tweak the result, for example, reassign outcomes. This is a useful exercise, but it's a limited view. I'm showing it here as fighting a paper dragon. We need to expand our scope and ask what specifically happens inside the box, how results are used, and where the data came from. In other words, we need to take a life cycle view of equity, and this is squarely within the purview of the data management community to which I belong. So let's now see how this may work in a concrete example. For this, let's consider Anne, a data scientist in a human resources department at a large retailer. Anne was tasked with developing a model that predicts the level of compensation to offer to successful job applicants to make sure that they are in fact successfully hired. Anne includes candidates' self-reported demographic data together with their employment histories as input. Following her company's best practices, she starts by splitting her data set into training, validation, and test sets. She then implements data pre-processing, joins the tables, and then interpolates missing values. And after that, she performs model selection and finally tuning and validation. And next, Anne considers the accuracy of the trained model and observes a disparity. Accuracy is lower for female applicants. This presents yet another kind of fairness issue. Considering the complexity of the data pre-processing pipeline, Anne has a long night of debugging ahead of her. Thankfully, Anne has a hunch. She goes back to data pre-processing and observes that the value of the attribute age is missing far more frequently for female applicants than for male applicants. And so she interrogates data interpolation. She compares the age distributions by gender and notices a disparity, namely that there are differences starting from the mid-30s. Anne revisits the data cleaning step and selects a state-of-the-art data imputation method to fill in age in applicant demographics. Let's extrapolate from Anne's experience and list some other sources of technical bias that may arise during data cleaning due specifically to incorrect modeling assumptions. Consider a form that gives job applicants a binary choice of gender and also allows to leave gender unspecified. Suppose that about half of the applicants identify as men and half as women, but that women are more likely to omit gender. Then, if mode imputation is used, and this is replacing a missing value with the most frequent value for that feature, and that's the default in scikit-learn, then all predominantly female unspecified gender values will be set to male. More generally, multi-class classification for missing value imputation will only use the most frequent class as the target variable, leading to a distortion for small population groups, because membership in these groups will never be imputed. Next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options, these individuals will leave gender unspecified. If mode imputation is used, then their gender will be set to male once again. A more sophisticated imputation method will still use values from the active domain of the feature, setting the missing values of gender to either male or female. This very simple example illustrates that technical bias can arise from an incomplete or incorrect choice of data representation. And importantly, it has been documented that data quality issues often disproportionately affect members of historically disadvantaged groups. And so we risk compounding technical bias due to data representation with pre-existing bias for such groups. In a recent line of work done jointly with the very talented Stefan Grafberger and Sebastian Schelter, we developed ML-Inspect, a lightweight data distribution debugger for data pre-processing pipelines of the kind that I described. The ML-Inspect library extracts logical query plans, modeled as directed acyclic graphs or DAGs, of pre-processing operators from machine learning pipelines that use popular libraries like Pandas and scikit-learn, and combine relational operations with estimator transformer pipelines. These plans are then used to automatically instrument the code and trace the impact of operators on properties like the distribution of sensitive groups in the data. In a related line of work, Sebastian Schelter and I, together with several of our students, are building FairPrep, a system that supports data scientists like Anne in their day-to-day battles with technical bias by enabling sound scientific experimentation. FairPrep helps incorporate new components, such as data pre-processing methods and fairness-enhancing interventions, into complex data science pipelines, and quantifies the effects of these components on multiple objectives, including accuracy and fairness of the classifiers that make part of these pipelines. In the remaining few minutes, I would like to address the final and perhaps the most difficult dimension, and that is outcome equity. It is concerned with whether and how we can assess and mitigate inequities that are outside the system's direct control. My thinking about outcome equity centers around interpretability and public disclosure. I like to think about interpretability using the nutritional label metaphor. The data management community has been studying systems and standards for metadata, provenance, and transparency for decades. The needs of data equity are once again bringing these favorite topics into the spotlight, but with a twist. To differentiate nutritional labels from more general forms of metadata, we articulate several properties. The labels should be comprehensible. They shouldn't be a complete and therefore overwhelming history of every processing step applied to produce the result. The information on a label must be short, simple, and clear. A label should be consultative, providing actionable information, not just descriptive metadata. Based on this information, consumers may cancel unused credit cards to improve their credit score, and job applicants may take a certification exam to improve their chances of being hired. Labels should also enable comparisons between related products or practices implying a standard. Finally, they should be composable and computable, derived automatically as data and decisions are produced by complex systems. In a recent article in the Wall Street Journal, I wrote about how this nutritional label metaphor can be used to provide the necessary insight into the hiring process to job seekers. And here's what such a label may look like for the application part of the process. I call this the posting label. A similar label, called a decision label, would be generated to explain the hiring outcome to an individual. As part of work on outcome equity, I'm also engaging with colleagues in social psychology at NYU to develop a framework that forms connections between interpretability and trust, and develops actionable explanations for a diversity of stakeholders, recognizing their unique perspectives and needs. An important point is that individuals and groups who distrust algorithms may be less likely to harness the potential benefits of new technology. And in this sense, interpretability intimately relates to equity. Recent studies found that individuals who are more familiar with data science and AI fear it less and are more optimistic about its potential societal impacts. Finally, I'd like to share that I'm also passionate about educating technical students about responsible data science. I developed and have been teaching courses on this topic at NYU. The course I'm showcasing here has already been taught for 3 years, and it has been able to attract an amazingly diverse and engaged group of students. All course materials are publicly available online at the link that I'm listing here. I invite all of you to use them and to give me feedback. I will also note that I have been developing a Data Responsibly comic book series. Its first volume has been translated into Spanish and French. I'm highlighting the Spanish edition here. Please take a look, let me know what you think, and share it broadly. Another set of activities that falls squarely under outcome equity is on developing public education materials and methodologies. I'm showing here a course that is currently being piloted at the Queens Public Library in New York City called We Are AI. We Are AI is a collaboration between the Center for Responsible AI at New York University, at the Tandon School of Engineering at NYU that I direct, between us and P2PU, Peer-to-Peer University, that's a public education nonprofit, and the Queens Public Library. Materials for this public education course include a series of videos and the comic book series, and both of these can be used on their own, independently of the course. Everything is in the open source on GitHub and on YouTube. I'm showcasing the comics here. Please take a look, share, and let me know what you think. Translating this series into Spanish is in our immediate plans. It's now time to wrap up, and I would like to leave you with a few parting thoughts, and then of course we will have time to discuss. In my talk, I gave a perspective on responsible data science and AI. I grounded this discussion in automated hiring tools, a specific use case that gave us ample opportunity to both appreciate the potential benefits of data science and AI in an important domain and to get a sense of the ethical and legal risks. It is clear to me that we technologists have an important role to play. But to make progress, we need to step outside our engineering comfort zone and start reasoning in terms of values and beliefs, in addition to checking results against known ground truths and optimizing for efficiency objectives. This seems high risk, but one of the upsides is being able to explain to our children what we do and why it matters. On a related note, an important thread that runs through our discussion is that we cannot fully automate responsibility. While some of the duties of carrying out the task of, say, legal compliance can in principle be assigned to an algorithm, the accountability for the decisions being made by a system always rests with a person. This person may be a decision maker or a regulator, a business leader or a software developer, or importantly, a member of the public. For this reason, I see the role of technologists such as myself, in helping build systems that expose the knobs of responsibility to people. Of course, the systems we're helping build are not simply technical. They are socio-legal technical. And in some sense, technology is the easy part. This means that to expose the knobs of responsibility to people, we must work together to create meaningful regulatory mechanisms. It's a topic on which I didn't have time to dwell today, but that I'm happy to discuss. I also see as part of our responsibility to help create a new generation of AI practitioners and an informed public. For a very engaging look at algorithms, computation, data, and the impacts on society, I recommend a recent book called The Age of the Algorithms by Serge Abitboul and Gilles Dovec. To quote from this book, algorithms are probably the most sophisticated tools that people have had at their disposal since the beginnings of human history. They have transformed science, industry, and society. They upset the concepts of work, property, government, private life, even humanity. Going easily from one extreme to the other, we rejoice that they make life easier for us, but fear that they will enslave us. Slightly paraphrasing from the book, creations of the human spirit, algorithms and AI are what we make them, and they will be what we want them to be. It's up to us to choose the world we want to live in. Thank you very much. The graphics that you saw in my talk today are due to the very talented Fala Arif Khan.
Thank you very much, Julia. I will now introduce Professor Marcelo Arenas, who will give a short commentary, and then afterwards we're going to open the floor for questions. Professor Arenas is a professor at the Department of Computer Science here at Universidad Católica, and also in the Institute for Mathematical and Computational Engineering. And he also happens to be my boss at the Millennium Institute for Foundational Research on Data, which he directs. Yeah, I'm going to leave it there because I can go on again also with Julia with a long resume, but that's not the whole point. So Marcelo, the floor is yours. Thank you.
Excellent introduction, Sebastian. So, I mean, just a few words, actually. So first, thank you very much, Julia, for a very interesting talk. I just want to make a few comments, actually. So obviously, the most interesting part will be the discussion in the Q&A session, right? So first of all, I want to say that we're all witnessing an immense progress in data science and AI. I mean, in particular, in the AI area, we're seeing some really impressive application. And all this is coming from an unprecedented amount of available data, right? And enormous computational power. And this brought the acceptance of data collection and analysis as a way to move society forward. And in this context, I mean, first, Julia gave us a very, I would say, a simplified and very useful definition of AI. I mean, what we're trying to do is to construct a system in which algorithms use data and make decisions on our behalf, right? This is very useful. And obviously the promise is to make our lives more convenient and all the things that Julia mentioned, in particular, well, to accelerate science, boost innovation, and transform society. But Julia gave us a big warning, right? So be careful with this technology. So in particular, she gave this very interesting example about hiring technology, which is a very useful technology that is used today that could help in improving and making this process more efficient. But that also Julia mentioned that I like very much that she mentioned that we should use it because humans are biased, right? So we have no choice but using machines to solve this problem. But they have a huge issue, right? That it has been observed, and Julia mentioned this study, that this application were perceived, sorry, in this study, I mean, they showed that male and white actually received substantially more callbacks than other people on the same resumes, right? So this study have shown that these tools are biased. And this is the main concern in this talk, I would say. It's a discrimination, which is often refers as bias. An important observation by Julia here is that bias is frequently used in the technical community, but is poorly understood. And a key question in this talk is, how can we know whether a tool works properly, in the sense that it's not discriminating? And in particular, if we think about the hiring example, what we would like to have is an appropriate hypothesis that could help us verifying that the tool selects employee who do well, right? And that is better than just flipping a coin. So a second important question in this talk is who is responsible for this, right? For checking and for whether these applications work properly, or for making these applications work properly. And an important message, I would say, in Julia's talk is that we are all responsible for this. And then Julia focused on bias in computer science. She mentioned this pre-existing bias that exists independently of an algorithm and has origins in society, the technical bias that are introduced by the operation of a technical system, and also this emerging bias that arises in a context of use, right? For example, if a system was designed with different users in mind, or if societal concept shift over time. And this led us to the key concept developed in this talk, which is data equity, which is about treating individuals differently depending on their endowments and needs, right, to provide equity of outcome. And the central part, I would say, of this talk was about the data, what Julia called data equity types. Well, first, representation equity, which refer to this deviation between the data records and the world that data is meant to represent, right? And here Julia's interpretation of bias in the data is that the reflection is distorted. And I would say that several ideas should be kept in mind. I mean, I don't want to take that much time, but something that I think it should be mentioned is that a reflection cannot know whether it is distorted, right? So, I mean, an outside observer has to take care of this. And in particular, if some interventions have to be designed, and I like very much this idea of intervention. I mean, if you decide that the representation of the world is inaccurate, then you have to design some intervention that could help in improving this representation. So it's also not up to the data or algorithm, it's up to the people to come to a consensus whether our representation is appropriate. And also something to keep in mind is that changing the reflection does not necessarily change the world. And well, Julia shows several examples there, I mean, of their work. I mean, very interesting, that probably will be discussed in the Q&A session. And then again, when we were talking about these data equity types, she talks about access equity, which is concerned with having access to information that she called theater data and models needed to mitigate inequity. And the point of view taken by Julia there is that what we should do is to mitigate technical bias. And Julia uses again the hiring example to clearly explain this point. So, I mean, if I remember correctly, she was saying that if no Black candidates are invited for job interview, then essentially we have three choices. You can change the input data, so increase the number of samples of some group or reduce the number of samples from some group, change the algorithm, right? Or finally change the results. So you can say reassign the outcomes. But Julia noticed that this is a limited view, that a broader view is necessary in this case, and she mentioned this idea of take a life cycle view of equity, which is something that is quite close to what we have been doing in databases, right? So I think it's it looks like a very promising idea. Well, again, very interesting work by Julia and colleagues was shown there that probably will be discussed, right? And finally, she mentioned outcome equity, which refers to unforeseen consequence beyond the direct control of the system. And the main question there was whether we can mitigate inequities that outside the system direct control. And Julia's idea about these centers around interpretability, and here I would like to mention that an important point is that people who are worried of algorithms may be less likely to reap the potential benefits of new technology. And I think Julia mentioned that the studies have found that individuals who are more familiar with AI fear this technology less. I mean, some interesting properties were discussed, the interesting properties of interpretability were discussed in Julian's talk. I mean, I will not mention that because it's going to take too much time, but similar to this idea of the nutritional labels, I mean, she talks about these decision labels that should be generated when explaining the output of a hiring system, why some people was hired or why some person was not hired. And something I would like to mention at the end is that a final thought in Julia's talk is that to make progress and that people working on technology need to keep the step outside of their engineering comfort zone. I like very much that, and start adding or start reasoning in terms of values and belief, which I think is something that we should do. And with that, well, thanks again, Julia, for this very interesting and enlightening perspective on responsible data science and AI.
Thank you, Marcelo. Thank you, Marcelo. And Julia has been posting in the chat box some links to the comics she has been mentioning. So now I'm going to open the floor for questions. Everyone is more than welcome to raise their own question. If you want to do it in Spanish, I can also translate it afterwards. If you want to write it on the chat box, you can do that as well. We have less than 30 minutes, I would say. So I think we have time for a number of questions. So anyone who wants to start or jump in, please do raise your hand or just speak.
So Sebastian, just one comment. There is a question in the chat, by the way.
Okay, good. Claudio. Okay. Do you want me to read it, Julia, or you can read it yours? I mean,
I can read it out loud,
okay,
if you like. Right. So that's a great question. I really like it. Claudio is asking, if I understood well, one of your claims is that we should really consider seriously individuals and work together on solutions. How is this contradicted by the increasing centralization of decisions by big tech companies, and thus the disregard of the subjectivity of the rest of us, particularly us who live in second league countries like Chile? So yes, incentives don't align in this space, right? Big tech companies are run by technocrats, kind of by definition, right? And technocrats want to have a say in how the world works because they think that they are the most competent and because they think that this is going to bring them the most profit. And that point of view, of course, is at odds with the interests of most stakeholders in society. And so one thing that is very, very difficult, and this relates directly to the outcome equity idea, is to find ways to really bring individuals who are impacted by these systems to the decision-making table. Not only at a point where, you know, you kind of as a formality invite people as this public engagement exercise and say, oh, we're about to deploy, you know, a bunch of sensors in your neighborhoods, and that's going to make your neighborhood safer. Do you agree or do you agree, right? I mean, that's not a way to do it, but we don't really know. We don't have a generalizable methodology for how to get people to help decide whether even a system is necessary for a particular question, right? So algorithmic hiring, actually, the systems there, I personally am not convinced that we need them. I think that this is an industry that creates the demand for itself somehow. And of course, old hiring practices were not great, but right, putting a technology patch on top of those is not necessarily going to fix the issue. So figuring out how to bring people to the table is a difficult question. And this is why, although I, of course, am an engineer and a computer scientist by training, you notice that at the end of my talk, I talked about education efforts, which is honestly is not something that I'm even trained to do. But I think that if we're serious about engineering society to make it better, we need to find ways to bring the public to the table and to speak in informed ways about these topics, to challenge the power of big companies and big governments. And this is challenging in the United States, and I can see how it's challenging in other countries as well. We need all hands on deck. Hence my culpability lineup, right? We all are responsible. So I'm in violent agreement with you, Claudio.
Thanks, Julia. More questions?
Can I make a question? Oh, yeah. So, Julia, I was just wondering whether you could say a bit more about the state of the art of the definitions of discrimination and bias. So, I mean, you mentioned this term several times. I'm sure in your talk actually. So, I'm thinking about like general and abstract definition of this more. I would say, I mean, you made an effort to have a more mathematical definition, right? So I'm just wondering what is the state of the art on that?
There are very many definitions. First of all, you know, even talking about bias, there are different kinds of bias, right? In statistics and in machine learning, we have been talking about bias as an inability of a model to capture the data. For example, if you're trying to fit a linear classifier, but the space is not linearly separable, that's bias. This is not the type of bias that we talk about here. Here, when people utter bias in the context of fairness, accountability, transparency, or ethics, they mean that the data does not represent society appropriately. So the first type of bias that people have been thinking about is this pre-existing bias that I discussed using the mirror metaphor. And even for that type of bias, there are many, many definitions that are in use, and many styles of definitions and many families that are mutually incompatible. And this came as a surprise, the fact that we cannot come up with kind of a grand definition of bias or fairness to rule them all. This came as a surprise to computer scientists. And I mean, I was one of them when I started getting into this space. But as soon as we actually started taking the conversation seriously from social scientists and legal scholars and philosophers, we understood that there is really no hope to find a single definition of bias or discrimination of fairness to rule them all, because what is fair is very context specific. It's very specific to a particular stakeholder group. It's specific to a cultural context, to a legal environment. So unfortunately here, we're gonna have to deal with a variety of definitions, many of them being at odds with each other. And I brought up a few examples, right? I showed you in my talk an example of bias and unfairness that talks about disparities in accuracy. Predictions are of lesser quality, for example, for women than for men. I also showed a kind of an unfairness that was due to imposing diversity constraints blindly, But if we counted all the fairness definitions that people came up with in the last few years, it would be hundreds. There are, however, some guiding principles that allow us to bring order to this mess. And these guiding principles are not mathematical. They are based on value frameworks. They tell us to step outside of this kind of mathematical reductionist box and to say, what is the actual objective here that you are trying to attain? And if there are multiple objectives, how do you trade them off in conversation with people being impacted and with the legal frameworks, etc.? So there's a lot of richness here.
Thank you. More questions?
Claudia tiene la mano.
And there's one in the chat box too.
Yes, I'm sorry, I have somebody at the door who's really, really persistent. I'm just going to tell them to wait for me. Just a moment.
También había una mano ahí, Sebastián, de Claudia, parece.
Ah, Claudia, ahí está. Creo que la de Pablo entró un segundo antes de que la levantara la mano Claudia, o yo, ¿no? Va a ir en orden, de repente podemos juntar las tres preguntas.
No hay discriminación en las preguntas.
No, es un algoritmo bias free.
Okay, I'm back.
I'm back. Okay, so I'm going to go with Pablo's question first, and then Claudia has raised her hand, and then we have Carlos' question. So Pablo asks in the chat, is there a record for any of these good hiring practices being applied today?
Good question. We know very little about what the various hiring tools are doing, in fact. And just this situation that we know very little would make anybody reasonable think that there's something fishy there, right? Because if you were proud of the way that you're doing things and it really works, why wouldn't you disclose it? There is, of course, the kind of competitive advantage argument being made, right? You don't want to disclose your algorithm to a competitor if it really works so well. But the utter lack of information about what data is used, how it's used, how these systems are validated, is telling us that there is a reason why these companies are being secretive. So I personally am of the opinion that unless your solution is such that it checks applicants against objectively verifiable criteria, like, do you have a particular degree, yes or no? Do you have the required number of years of Python programming experience, yes or no? And then once you get that pool of candidates, and you have some diversity constraints, for example, you can take a stratified sample, right? Just picking a random subset of the people who meet the requirements subject to your diversity constraints, that type of a solution is going to do as well as anything that anybody is selling to us for millions of dollars. To answer this another way, I don't actually know of a commercial solution in the algorithmic hiring space that has been validated appropriately. Like to the same standard that we would hold a car, I don't know, that's about to go to market, or a bridge. These standards are just not there. And it's very sad because this is a multi-billion-dollar industry.
Claudia?
Hi, thank you, Sebastian. Julia, first, thank you, because I've used your materials a lot in my courses, so thank you for that. And I have two questions. One of them is these two definitions of equity, well, you have three, but the two first definitions of equity about representation and access. I'm wondering, I see them as connected. I sort of think that you need access before running any kind of intervention to correct representation. And I want to see if that is true, or if you see somehow mechanisms that could allow developers or someone to try to somehow fix some sort of unequal or unfair results without having access to the actual data that is used to generate those recommendations. And that's one thing. And the other thing, it's thinking about the nutritional labels. How do you envision that would somehow help users or people to make decisions on that? Like, one thing is that you have the information and that is easy to understand, but then the next step is you need to like have some sort of decision making to enable people to do something about that. And what are your thoughts about what's next after the information, after getting information?
Great questions, both of them. I'm just taking a note so I don't forget. So the first one was about whether the equity dimensions really are orthogonal, right? Can we speak about representation equity as truly separate from access equity and truly separate from outcome equity? And implicit in this question, Claudia, of course, is a disagreement, and I agree with your disagreement. It actually is very difficult to decouple cleanly these dimensions. Now, to the specific question about, can you actually be trying to mitigate, diagnose, or mitigate a disparity, like a lack of fairness, without access to the real data set? I think that there are some methods for this. We have, for example, methods for privacy preserving synthetic data generation, right? That can allow you to generate a data set that is statistically similar to the real data, but that provably preserves the privacy of individuals whose data it contains. And you can use, and I've been advocating for this, you can use either these models that are differentially private or actual synthetic data sets that you draw from such models in support of algorithmic transparency. When you as a hiring company say, oh, I cannot disclose to you what were all the applicants' demographics, please give me a synthetic data set that is similar to the data on which you worked, and then I can run it through my tests and I can see whether I can break your model or if I can confirm that it in fact works. So in that case, I think that it's hopeful, but generally, yes, it's a very, very difficult exercise. And this is also part of the difficulty for technologists to engage and engineers to engage in this work that is social and legal, is that our point of view is always kind of reductionist, right? We want to break things up into boxes and make sure that there are as few wires between the boxes as possible. You don't want dependencies. So that's a reductionist kind of point of view that allows us to get a handle on these complex systems. And sociologists intrinsically don't believe in that, for example, right? They say you can't really decouple all of these effects. So figuring out how to both reduce and not reduce is the devil here. Regarding nutritional labels and how they can be used, right? So this is, again, a wonderful point. People have been talking about fairness in general and interpretability in general, but these are not useful concepts when you talk about them in general, right? You need to know with nutritional labels, what are you explaining to whom and what will they do with that information? For what purpose? And this is something that my colleagues, Tessa West, Jay Van Bavel, and I write in that Nature Machine Intelligence article. So when you create a nutritional label for job seekers, just to be concrete, in my recent piece, I wrote about two types of these labels. One of them is a posting label that before you apply, you will be told how the company will use your data to screen you. And the purpose of that label is to solicit informed consent. If you see that label and you agree with the data use practices, you apply. If you withhold your consent, you don't apply. The purpose of another kind of a label that explains the decision, I call it the decision label, is going to be, here's the information that we used about you, here's how you compared against others. And the purpose of this label is recourse, to enable recourse, to allow a person to challenge the decision, to say, you shouldn't have used this data about me because I didn't tell you you can use my Twitter feed. Or this signal that you used, this is discriminatory because I'm disabled. So you should not have been using that information. Another reason for that label would be actually to allow people to improve themselves, to become more competitive, right? So if you tell me that I, for example, wasn't given a credit card because my credit line is too high, I'm going to go and pay off a particular line of credit so that I'm more competitive in the future. Or I'll take a qualification exam because that's standing between me and the position. So that's a very important point, right? Everything needs to be context specific, application specific. That's why I zoomed in on hiring, because we need to be concrete on something. And always asking, are the people actually being able to act on the information that you give them?
Thank you so much.
Thank you.
Thanks, Julia. We still have like 5 or 7 minutes for additional questions. If anyone wants to jump in or write it in the chat.
I suppose we're starting to lose people.
Well, I'm going to use my moderator powers to ask you one question regarding actually, it's not about the technical aspect of your talk, but more about in terms of education. So a lot of the topics you've been discussing, what's your vision of how we should move forward in a university to teach these concepts, either at the undergrad or graduate level? Because it seems to me that everyone would agree that biases in algorithms, for example, is a very relevant topic. I mean, that's actually the whole purpose of this talk, right? And of bringing you here. But at the same time, it seems that when you start talking to those who need to make a decision, for example, policymakers or experts in areas outside computer science, either in the humanities or in social sciences, you have a lot of technical barriers, either of understanding the way it works, algorithms, or in the case of policymakers or even legislators who are concerned about issues like this. Sometimes the proposals, you kind of wonder whether the remedy they're proposing through regulation is worse than the problem that they're trying to address. And I think a lot of it, and that's actually my question, is that we have a lack of understanding in terms of education about how to, bring these concepts to everyone who's not in the, not knowledgeable in computer science or in technical aspects, actually, for that matter. So I see that you are kind of very aware about this because that's why you have the comments and all that. But I just wanted to have your experience from us in the university. What is the kind of appropriate way of moving forward on top of having you and this conference? But I'm thinking in terms of classes or programs or outreach. I don't know. So I just wanted to have your take on that.
Yeah, that's a great question, Sebastian. It's very, very difficult, right? And the main issue here is that very few people dare to teach topics at this intersection, right? Because you need to be the self-proclaimed expert in technology and in ethics. And, I'm really terrified, honestly, speaking about ethics, because I'm not an ethicist, right? I took like one philosophy class in undergrad and one philosophy class as a PhD student. So generally just this comfort level lacks even among us, right, instructors. This is not like you having been teaching computer science databases, now you have to go pick up a compiler's book, you teach yourself compilers, and you can teach compilers. It's very different. It's frightening. And this is why I went with the comics, is because I think that if we laugh about this a little bit, we can relax. For us, the technical people, I think it's a little bit easier to cross over and learn the other side. This may be hubris, but this is kind of my intuition. It's because papers, for example, in law are written in plain language, in English or in Spanish in your case, right? While our papers are written in formulas. So a lawyer is not going to understand our papers, but we can read theirs. So because we are, to use a legal term, the least cost avoider, it's easier for us, then maybe the burden is higher on us to go and kind of teach ourselves all of these topics. And honestly, they're very interesting. I mean, of course, it depends on who you talk to, but I think it's pretty nice. It opens your mind, and then relax about it and just say, I dare to teach ethics because I am a human, and the machine can't teach me because it's a machine. It doesn't have ethics, it doesn't have agency, it doesn't have a sense of humor. It's up to me to do this. So I think that's the first kind of part, is just getting over our own insecurities. And then after that, again, figuring out how to make people comfortable with these topics, because we do really need input from as broad a group of individuals as we can gather, because the harms of these systems, no matter, so this is an argument against technocracy, right? No matter how smart you are, you cannot simultaneously put yourself in everybody else's shoes. You don't know how somebody may be experiencing a disadvantage due to the use of a particular algorithmic hiring system, for example, right? Your resume passes. someone else's doesn't persistently. So you do need people to give you feedback, right? So there is, again, a utilitarian argument here to be made for this public engagement and public education. But for a person to read a nutritional label, they need to understand what a calorie is, right? Or the equivalent of a calorie. So it's an ocean to boil here. But really, we do need to go out. I do really feel that, you know, a choice between writing another paper with another algorithm in it versus spending a bit of your time developing a course for the general public, the course will be more impactful. The problem with tech ethics is not that we need more algorithms, and we have enough of those. We need people at the table.